So welcome, thanks for joining the talk. We're going to start with a demo. So unfortunately I couldn't attend most of the talks in this room today, but you all, I think, very well know that there's lots of open source software available for IoT, like for doing like protocol stuff, for doing device management. Like we briefly spoke about software upgrades and device management just before. But how do you put everything together, and how do you go from blinking an LED on your Arduino kind of stuff to something more real and more of an end-to-end solution? What if I wear UPS or FedEx, or like I should probably name a third one just to make not make any unnecessary publicity, and I want to provide my customer with a solution to do asset tracking management, right? I have those super valuable parcels with I don't know, like say this is Mona Lisa, or this is super expensive food or medical equipment, and the customer needs to know whether the package is traveling safely and not being dropped, not being opened, temperature remains in a given range, etc. So how do we do that? How do we get to a point where we have, at the end of the day, we have some kind of dashboard? So that might not actually be for the customer himself or herself. This is maybe more for for FedEx and UPS, but we could very well imagine a similar UI or similar application for the end user. I want the list of my trucks, the list of parcels within each truck, and the live telemetry coming from the parcels, right? And so apparently the room here is way colder, at least if you can say that, than the building K, where we are doing the same demo at the Eclipse booth. But this is literally the telemetry coming from the parcel. And maybe this is something that's sensitive to light. What happens if I open up the box? No, not supposed to happen. This is way too much. So that's basically the use case. How do we implement it, and with what kind of technology? So maybe let's try with a couple of slides as a support for the conversation. The idea really is like we want to track the goods and like all the parcels, so that if I'm UPS or FedEx, I can optimize maybe the way the trucks will deliver the parcels, like the ones that are more critical. I can sell some services to my customers, and I mean, all in all, are really like generating value, but in the right way, right? I mean, maybe this means money for the company involved, but this means ideally like maybe a better world. Like that's what IoT should be about. So the way it's implemented, and that's some of the projects I'll be sort of name dropping in the presentation, is, so it's all the way with the sensors. Some of you might have spotted the sensor within the box. Obviously it's not just a Lego plastic box. This is a TI sensor tag. So like this is really an off-the-shelf Bluetooth low energy beacon, if you will, that has humidity, pressure, temperature, etc. sensors on it. And the goal is basically to take the telemetry from this guy all the way to the internet. So how do we like bridge the gap there? First, it starts with a gateway. So either in the warehouse or on the trucks themselves, you would find a gateway providing basically the connectivity. On one hand, the gateway, that's really what a gateway does, passing some messages from one interface to the other, pretty much. On one side, that would be Bluetooth low energy, right, to interact with the sensors. And what you want at the end of the day is send the data over the internet. So for that, we rely on Eclipse Cura, and I'll dive a bit deeper into what it is, but think about Cura as OpenWRT on steroids, I would say. It's basically a good old router kind of stack, and like if you want to use, if your board, if your device, if your gateway has Wi-Fi and a cellular modem and Ethernet, maybe you want to configure all those interfaces so that maybe the Wi-Fi behaves as a hotspot and blah blah blah. So Cura would certainly do that, but also allow you to create custom applications on top of and deploy your own applications on top of. In my case, it's a very simple app/plugin that will every 5 seconds or so discover all the sensors in proximity, and how depending on how many packages I have, for all of them I will like grab the telemetry data and do what? Send the data to the cloud. And what's on the cloud side, what Cura does is basically use MQTT as the protocol for the communication. One option would be use like commercial IoT clouds out there. Basically, all of them support MQTT, because MQTT is sort of like the de facto standard now, open standard for all things IoT messaging. Or you can rely on Eclipse Kapua, which is basically the integrated platform for all the services that you basically require on your server side, all the way from device management to storing the data to having a digital twin API, and we'll talk about more maybe about digital twin later on. This is all those services, so basically all the Docker containers sort of that you need that are IoT specific would be part of Kapua. And in my demo and what you've seen, basically the dashboard that you've seen is a simple HTML and JavaScript application that you can see the screenshot of over there that talks to the Kapua APIs to retrieve the list of trucks, retrieve the list of parcels, etc., etc. And Kapua, being based on containers and being cloud native, if you will, is meant to run on things like Kubernetes, or in my particular case, this is OpenShift running on Google Cloud. But it could be like literally any kind of variation of maybe you have all the microservices spread across different data centers, and you have and you want to scale up your data store. You can easily do that, etc., etc. So that's kind of the end-to-end, the end-to-end solution. And it sort of illustrates that when you really care about building an actual end-to-end IoT solution, there's basically three stacks of softwares, three major areas where you need to work and start building software for. One is the devices themselves, like what I call the constraint devices, really the microcontrollers, if you will. Anything that's not necessarily or very likely not IP capable kind of device, which very likely will use a gateway to get the connectivity. And so what's in the scope of a gateway, we'll talk about that in just a minute. And then the cloud. The goal being, I briefly mentioned, like, especially for servers, there's lots of like IoT cloud platforms out there, very commercial, very close, very proprietary, as opposed to if you are to build an IoT solution, I would think that, I mean, the server especially would need to be, like, if it is based on open source and based on open standards, it means that it's way easier to start thinking, oh, you know what, I don't quite like MQTT for my use case, it just doesn't scale, or it's like, that's not the protocol I want to use, I want to use, say, co-op. If you have a server stack that's like pretty modular and even more so open source, replacing the connectivity layer, your broker, by something different shouldn't be a big deal. Good luck with that on Azure IoT or AWS IoT, and etc. Right? And I mean, that's the whole point of basing the IoT on top of open source. I don't think I need to convince you about that. So what do we do at Eclipse around IoT? Some of you might be already using, I would hope so, some of the stuff coming out of Eclipse. We have 30 different open source projects, all the way from fairly basic building blocks, if you will, like Eclipse Paho or Eclipse Mosquito. If you guys care about MQTT, you've used those clients and server projects respectively for doing your MQTT stuff. And we have a very active community that basically try and address the three stacks that agents mentioned. And if you look at the history, and this is where certainly the IoT community is headed, we're going from like having very small, very independent building blocks like a device management stack that you would put in your embedded device firmware, to a protocol, a server-side implementation of the MQTT protocol, etc., etc. This is really helpful. Only when you really want to build this solution, like end-to-end solution, you don't really want to have to integrate all the bits yourself. And ideally, when it comes to building the gateway, you're not pulling Paho on one end and another open source library from the other, etc., and you have some kind of integrated framework, right? So for the constrained devices, I probably won't talk about that too much, especially since in the demo I've shown you the device is really literally an off-the-shelf very commercial, very well, I don't think it's closed actually. I think the firmware for these guys is open, but I didn't have to develop anything specific for this particular device. But maybe I would like to, like if I want to lower the cost of having many beacons in my solution, I will actually be building the firmware for my constrained devices. In which case, if there is one thing that you need to remember, and this is aligned with what we've heard in the talk just before, there's I guess two things. One is having a good hardware abstraction layer when it comes to building your embedded application, so that ideally, if you start like your solution on, I don't know, an Atmel microcontroller, and you want to move to a Cortex more like powerful kind of device, ideally you don't have to rewrite everything. So there are some things that could help from the Eclipse community, like Eclipse Edge. Another important aspect of constrained devices, especially, is if you can't update them, like you don't really own the devices, because I mean we've seen all the bad shit that can happen if someone gets control of the device. So there is a very good open standard out there for doing device management of constrained devices. It's called lightweight M2M. You can get the reference implementations from Eclipse, and so that's called Eclipse Wakayama, and there's actually lots of cellular, in particular cellular modules manufacturers who already bake lightweight M2M into the firmware. So like, by default, they're already, like, you can already start managing them from your from server and do over-the-air upgrade, like we've seen just before. Gateway-wise, what are we talking about? We're talking about, like I said, an OpenWRT kind of stack on steroids. And what do I mean by steroids is, like, we care about IoT, so not only do we want a router to provide the connectivity, we want to provide the connectivity to sensors, we want to provide reliable connectivity on the shop floor if we care about industrial IoT use cases. So this is one. But we also want to enable, either like your developers within your company, or possibly your customers and your partners, to develop apps on top of the gateway. So you need some kind of application container and the ability to extend the functionality of the gateway, like, and leveraging the fact that the gateway takes care of keeping the connectivity up and running as much as possible. You want an app that will leverage some kind of Bluetooth low energy driver, or even better, a TI sensor tag driver that will already be part of the stack, and start like using the data and just start building your IoT gateway application. So that's what Eclipse Cura is all about. And so it's a framework that takes care of all the networking stuff, and it's operating system agnostic, which means that you can run Cura on Fedora, on Debian, even on Windows. It will always be the same way to manage the Wi-Fi. It will always be the same APIs to configure a DMZ or whatever you want to do, purely from a networking perspective. And then on top of that, again, very much operating system and hardware agnostic. You can start tinkering with and playing, retrieving the location of your device through the standard GPS API of Eclipse Cura. You can start interacting with a Modbus industrial piece of equipment, and that's really the scope of Eclipse Cura, and it's being used by, I mean, you can run it on any kind of Linux-based or Windows-based device, or you can even get off-the-shelf gateways that have Cura built into them. And as opposed to this guy, which I very likely don't want to put on the actual roof of an actual truck, you can probably get like a ruggedized version of a gateway that runs the very same software that I'm demonstrating here, right? So this is not a talk about like home automation, but like if you care more about a specialized distribution of a gateway stack for home automation, you may have heard about OpenHub or Eclipse Smart Home. So this is essentially like a targeted like all the drivers you would need to do Philips Hue and whatever else home automation gadget you have, you can get from Eclipse Smart Home. And then I'll keep the last 5 minutes or so of my talk to focus on maybe the area where it matters the most to have good open source stuff available. This is on the cloud side of things. And so we have, again, we have lots of building blocks. and we're working towards an integrated stack. One really interesting area is around device management. So again, lightweight M2M is a very important standard that you should look at if you care about device management. So Leshan is sort of the counterpart server side of Eclipse Wakayama, and it's based on Java. But a really cool, a really interesting project from Eclipse is Eclipse hawkBit, which is how do you, like say I have 1,000 of those and I need to upgrade the software, and the software is, I don't know, 100 megabytes worth of like a binary blob, whatever that is, and I want a solution so that first, I don't want to kill my network when my 1,000 devices will start downloading the binaries all at the same time. And if they really do that and all update the software all at the very same time, and I have a nasty bug, and it's basically a very buggy firmware, and I'm going to break all my devices all at the same time. So hawkBit is the orchestrator, if you will, of software upgrade rollouts and software upgrade campaigns. So how do I make it so that I only upgrade my devices that are located in southern France first, and if and let's do that over the course of 7 days. If I see that there is a failure rate above 2%, then I stop the upgrade campaign altogether, right? This kind of functionality associated with the UI, the dashboard, so that you can see how many % of your fleet is running that particular version of the firmware. How do you model the dependency between all the software artifacts and software components? This is what Eclipse hawkBit is all about, and I think that's pretty unique in the open source community. So you might want to look at that. Provides all kinds of APIs for integrating and creating your own agents if what you want to do is manage and operate over lightweight M2M. You can certainly do that. Maybe you want to use hawkBit to also roll out new Docker containers updates at the edge. That could certainly work as well. But that's kind of like, yeah, you can certainly deploy hawkBit, deploy Leshan, deploy Eclipse Mosquito so that you have an MQTT broker. But at some point you need some integration, and you need some common notion and common knowledge of what's a device in the first place. Like, I don't want to duplicate the effort of authenticating my devices when they start talking to my MQTT server, authenticating them when they want to do a software upgrade, authenticating them when there is a need for storing the data that they just sent. So this is what Eclipse Kapua is all about. So defining all the APIs, all the microservices, if you will, that are required as part of the stack. So what should be in my device registry in the first place? What's a device identity? What's required to uniquely identify the device, to have the security credentials, and have this in a very like abstract way. So that's Kapua. And so once Kapua has all those like microservices defined, it's fairly easy to provide some kind of UI, management console, management dashboard, which I could actually, this is a part of the demo that I should have shown earlier, but basically, how do I like navigate my fleet of devices? Truck 3 with the green light is actually that particular truck here, and I could go if my session is still valid, and I would hope it is. Yep, I could look at what are the software packages that my particular device is running. So for that, it would make a query to the device registry, very likely, etc., etc. I can have a look at what's in my data store. I can configure new users with specific roles, specific ACLs, so that John may be able to read the telemetry information, and Jane will be able to only manage the settings of the applications that run at the edge. So that's really literally what Eclipse Kapua is all about. And what happens under the hood is that for all the microservices that are being defined, there might be, I mean, the functionality might be an existing Eclipse building block, like maybe for the device registry underneath Eclipse Kapua, although that's not the case today, but I would hope that's what will happen. It could be implemented by means of hawkBit, or maybe this is your own existing LDAP that you want to sort of hook to the particular service. For the data store, by default, Kapua would store some of the data, sort of the static metadata in the MySQL database, and the telemetry will be an Elasticsearch database. You want to replace that because you have an existing InfluxDB database you want to leverage. It's fairly easy to do. And so that's really the goal of Eclipse Kapua, and it's again cloud native. So the goal is that you can easily deploy on a public cloud, private cloud, hybrid cloud. It's really your call, and it's really depending on your need in terms of whether you need to scale maybe the connectivity layer, because you're going to have so many devices connecting, and in which case the connectivity layer will actually be Eclipse Hono, which is basically a generic infrastructure for taking care of ingesting data coming from MQTT devices, co-op devices, and whatnot, and make sure that you have a consistent API so that you can consume the telemetry data without having to bother what was the initial, the protocol initially being used. So that's what we do. Lots of name dropping. I would hope that you have a look at the projects. There's lots of companies that actually, and for me this is sort of gold, when you have like a company that starts saying that they actually start shipping products that are being based on Eclipse IoT, and there's certainly a lot for the gateways. Like I said, you can get off-the-shelf gateways that support that are compatible, if you will, with Eclipse Cura. Server side, there's also a lot of common ground between some commercial platforms out there and Eclipse IoT. And we try and do, and I want to make sure to sort of pitch that before to open it up for questions. There's a lot happening in our open source community, so Virtual IoT Meetup, if you want to, like every other week we have webinars, if you want to learn about what's happening in the open source IoT community at large. It's literally a commercial pitch free. It's really like we want to hear about open source, cool open source stuff being built, so check that out. We do test beds. This is actually a test bed meant to demonstrate how the technology can be used for real use cases. This is our website. Get involved, join the mailing list. If you use the projects, come and find me after the talk, or like if you have an idea of a cool open source project you'd like to contribute, chances are the Eclipse IoT community could be a good place. There's already a lot happening, so it might make sense for you. And one final plug, and we'll share the results of that particular survey. We've been doing that for 3 or 4 years. We ran a developer survey. If you wouldn't mind spending 8 or 10 minutes of your time telling us what protocols you use, what programming language you care the most about when it comes to IoT, whether you care more about server-side stuff or blah, blah, blah. This is open until I think the end of next month. All the data sets are going to be published, so it's not like we're going to make money out of it or anything. It's more about understanding the trends, understanding what should be in the IoT dev room next year, and things like that. So with that, I think that's the end of my presentation. This is where to find me, and I have some time for questions.
Great.
Thank you. And the demo worked.
Yeah. So yeah, we have a few more minutes for questions. Everything was very clear.
You mentioned digital twin.
Right, that's correct. Thanks for that. The question is, I did mention digital twin, although I briefly passed over that as part of the presentation. My bad. The project name is Eclipse Ditto. It is fairly new, but the code is there and it actually works. What's the idea behind digital twin? One thing that I have been doing here, like as part of my demo, is, well, I want to retrieve the telemetry coming from the sensors, and it turns out the sensor is actually connected at this point, so like I get data. One thing that a digital twin API allow you to do is basically have a digital representation of your physical asset, so that at the end of the day it doesn't really matter whether the device is currently accessible or not. You still want somehow to know what's the latest temperature that the device has reported, or if we're talking about an electric a light bulb, the light bulb might not be connected at a given time, but yet I want to toggle the switch on, off, and have the digital twin represent what the physical state is or should be, should the device be connected. And this is the scope of like digital twin in general, and there's lots of platforms out there who have their own sort of like way of doing digital twin, and Ditto is trying to do that as well. But yeah, you should check it out. There's lots of documentation already there, lots of demos, and this is actually a note to myself. I should try and integrate that as part of the demo to see what happens when I just remove the battery. Can we still do useful stuff? Yeah.
You can take one more question. This one over there.
Is there a chance to model some ownership relation as a user? I own
Right.
that device.
Right. So what's do we somehow address the modeling the ownership of the device and ownership therefore of the data? I guess this is not. I don't think any of the Eclipse projects do that. We have an interesting initiative called Eclipse Voto, which might be like the closest thing to allowing that, and basically have models to describe the capabilities of the devices, and I guess you could combine that with maybe other models, other descriptions of who's owning what and what's kind of maybe the hierarchy of the capabilities, hierarchy of the data, and then map that to the roles in Kapua and stuff like that. But yeah.
Okay, thanks a lot.
Thank you very much.